The lung's ability to heal depends on the remarkable dialogue between alveolar epithelial type 2 cells and their neighbouring fibroblasts. In this review, we explore how this cellular conversation determines whether the lung regenerates or progresses towards fibrosis. Alveoli rely on AT2 cells to replenish the epithelium and restore gas exchange after injury. Surrounding them are lipofibroblasts, which can either support regeneration or transition into activated myofibroblasts that drive fibrosis. The outcome of injury depends on reciprocal paracrine signaling between these two compartments. The long-standing debate over whether epithelial injury or mesenchymal activation initiates fibrosis has shifted. New lineage tracing and single-cell studies show that epithelial damage produces AT2 to AT1 intermediate states, and when these transitional cells stall, combined with fibroblast plasticity, they become central drivers of fibrotic remodeling. A major conceptual shift is the recognition that fibroblasts are not terminally fixed. LIFs can convert into activated myofibroblasts. Importantly, this process is reversible, offering new therapeutic opportunities to promote fibrosis resolution. Key signaling pathways regulate both epithelial transitions and fibroblast states. AREG to EGFR activity sustains stalled intermediates. TGF-beta drives myofibroblast differentiation, while FGF10 to FGFR2b signaling preserves AT2 survival and regeneration. These pathways define the molecular language between the epithelium and mesenchyme. The WI-based alveolosphere system offers a human-relevant platform to study epithelial to mesenchymal interactions and test drugs. By manipulating fibroblast states and monitoring AT2 differentiation, it enables screening of FDA-approved compounds that reverse myofibroblast activation or promote AT2 to AT1 regeneration. Current evidence points to a unified model where epithelial intermediates, fibroblast states, and key signaling pathways determine whether lung injury resolves or progresses. Understanding this dialogue enables therapies that halt fibrosis and promote regeneration. WI38-based platforms and targeted pathways such as those involving FGF10, TGF-beta and microRNAs offer promising avenues.